Hey guys, today we're going to be taking a look at this 12 volt 100 amp hour battery by VoltGo. This is a lithium iron phosphate chemistry battery which has a superior cycle life and is going to last you a really long time. So this battery here actually has an IP67 rating, which means it is a marine grade battery. You can safely use this out in your boat as a trolling motor or whatever you want to use it for. So this battery here also comes UL listed, which is really great to have that designation because you know it is going to be a safe battery. So let's take a closer look at the case and talk a little bit more about its specifications. And on the front of the battery we have VoltGo, we have Bluetooth, heated, IP65, and we have a detachable design. On the top of the battery here you can see we have operation voltage of 10 to 14, charging voltage 14 plus or minus 0.2 volts, maximum charging current of 100 amps, maximum discharge current of 100 amps, recommended charging current of 30 amps, and we also have a charging temperature range of minus 20 to plus 45 degrees. And that is because this battery actually has heating, and we have discharge temperature range minus 20 to plus 55. Down here you can see we have our Bluetooth ID, and here it comes with the sticker on the battery. We also have epoxied terminals on the positive and negative, and a very heavy duty nylon strap that is easily removable by just working it around these pieces of plastic here. On the bottom of the battery, we have these little shoes here for mounting brackets, and that is going to be here. So you can actually mount these either to the wall or to the floor, just depending on which orientation you put the battery. The battery weighs in at 24 pounds, 6 ounces. Now this battery here can be seriesed up into 4 to make a 48 volt pack, or 3 for 36 or 2 for 24. These are series capable batteries. So next let's perform a discharge test and see if we can actually get 100 amp hours out of this 100 amp hour battery. Okay, I have my discharge test ready to go. So let's pre-charge the capacitors. Okay, introduce my load. And now you can see there we are discharging at about 26.5 amps. So I'm going to let this test run and we'll see if we'll get our 100 amp hours out of this new battery. And the inverter is starting to chirp, so we are getting pretty close to done here. And the results are in. We are 102.185 amp hours out of the 100 amp hour battery, so I'm happy to say this test is a pass. And now my favorite part, opening this battery up. Now it should be fairly simple. You can see we just got to take these off here and the battery should open right up. And once you have all the screws removed, the lid comes off. So you can see here on the positive terminal and the negative terminal, we have these little plastic caps in order to keep an insulation between the metal and the metal. Even though it looks like these posts here are actually going to land right around here, which is away from any metal inside the battery. We have a gasket inside the lid here that's going to run the perimeter around the battery in order to give yourself a watertight seal. And this BMS looks really nice. So there's the BMS. It's a ZTSP04S057-FET. Then we have a V1.1. And the wire gauge sizes are, we have a 6 gauge wire coming up to the battery positive, and we have 2 8 gauge black wires going to the battery negative, as well as 2 8 gauge wires coming from the negative of the battery up to the BMS. Let's get this pack out and take a closer look. Okay, hopefully this is just going to slide right out for us. So I see a heat pad here on the side. We're going to test that. And then in between the BMS and the batteries, we have another heat pad here. Okay, and here we have the top of the cells, them screwed in and then laser welded around here. We do have a hump. We have a threaded screw hole here for the balance lead cables. This is B3, B1, B2, and main positive, main negative. In order for me to actually scan the QR codes to find out what cells these are on my own, I would have to unscrew the tension bar, remove the balance lead cables to get this upper piece of plastic off, which is going to be a pain in the butt. So I reached out to the company. They told me that these are ETC cells, which is a high quality grade A manufacturer of lithium iron phosphate cells. These cells themselves are actually UL listed. So the whole pack itself, the build quality is UL listed, as well as the cells are UL listed themselves. This here looks to be some sort of sensor. So that sensor comes across the side here and comes to this little box. Yeah, that runs up over to here. What this is fire suppression. So this battery actually has fire suppression as well. And the way that it works is once this probe here heats up, it sends that heat into this pack, which is then going to spray a foam outside of here and is going to encase the battery in a foam, which is then going to suppress any type of fire that may happen inside of this pack. Lithium iron phosphate is a very stable chemistry. The likelihood of a fire is virtually zero. In order for them to get their UL listing, they need to have some sort of fire suppression device. I've never actually seen one of these before. That is so cool. So this battery has fire suppression. Okay, so it looks like we have one temperature sensor that was tucked under the bus bar here, and a second one tucked under, touching the top of the cell. We're going to test these here. I want to see these heat pads heat up. So we also have switching, looks like we have a couple of switching ports, or no, we have a RS485 port here and a SW port. We also have a LED port over here on the left. So it looks really nice. Looks like a really nice heavy duty BMS. All the wires are connected nice and tight. All this here, this is going to be for the heater. So that is going to run down into the heat pad here, and then it comes out this side and runs over down to the thermal switch here, which then runs through onto this pad and then runs back up to the positive here. So that's going to be the switching up here on the BMS. Okay, let's take a look at what the app shows. So this is the app here. Now I've connected to the device. On the lid, there is the code for which device is yours as far as Bluetooth, because everything that has a Bluetooth signal is going to show up on this app when you search. So you can see there we're charging, we're at 0% because we just did our discharge test. But you can see we have a 5 amp current going in. We have 18 degrees Celsius, 19 degrees Celsius / 66 degrees Fahrenheit. You can look under here under details. You can see the different cell voltages. Now this is depleted, so the cell voltages are going to be a little different. If we were at a high state of charge, I would expect them to be more level. You can see we have the PCB, which is the BMS temperature. And then we have the temperature sensor 1, temperature sensor 2, which are these two sensors here on the top. And then under settings, there's not much you can change here. It just shows the app version, model ID. So I'm going to leave that alone. But yeah, very interesting app. Let's see what happens if I chill. Okay, there you can see now it says protect up at the top above the battery icon. And we're still showing 20 degrees. Let's go on the details. There you can see -7 degrees. And that actually is temperature sensor number 1. So that was lucky. Let's heat that back up. And you can see temperature sensor number 2 dropping right at 0. We should see it drop out 1 degree, 0, and there you go. So now the heat pads have turned on. You can see the lines, we are heating. So that is starting to heat right now. And we can check that by going to home. So you can see and protect. So now let's heat this back up. And now we're on standby and we've commenced charging again. So that's really neat. Let's try over temperature. Yeah, there we go in protection mode. And you can see actually there we're at 100 degrees Celsius. We'll go to the details. 91 degrees Celsius. So let's cool this back down. And charging has started again. Yep. And let's test the other sensor just for comparing. And there you go, we have disconnected. And you can see we're in protection mode there. So let's cool this back down. Standby and charging again. So that is really nice. Okay, I'm gonna put this battery back together. This test is done. We passed low temp, we passed the heat pads, everything's passed. So let me put this back together and we'll talk a little bit more. And there you go, we have it all back together. I'm just charging it back up now, as you can see on the app. So amazing battery, like fire suppression, heating, really cool design. So if you like this video, stay tuned. I have more from this company coming up. Actually, you know what? Since you stayed around till the end, I'll give you a little preview. So this is their 24 volt, 200 amp hour battery. But wait, there's more. And this is their 48 volt, 100 amp hour. So I'm gonna be taking a look at these batteries as well. And we're gonna check them out and see if they're just as good as their 100 amp hour battery, which I have no doubt that they are. So stay tuned for that video in the future. And as always, thank you very much for watching. Bye.